In order to demonstrate our understanding of how the Python environment does indeed integrate with the operating system, a common question we may run into on an interview, and certainly one that we should want to become familiar with, is the idea of what is the difference between the operating system path and the Python path as represented in the environment variables and queryable from the Python programming language. To help us in the answering of this question, all we have to do is get into a console or terminal prompt on the operating system, and no matter if we're running on Linux or OS X or even Microsoft Windows, we should be able to query the path as we see here, either prefixed by the $sign on POSIX systems or by using the % delimiters on either side on Microsoft Windows. Regardless of whether we're using Microsoft Windows or Linux command prompts, therefore, the operating system will respond by showing us a detailed listing of all of the file directories that it will search, as well as the order in which they will be searched when looking for an executable program. Because Python is an executable program on all these operating environments, note that we will see a folder that will include our Python executable, but note here also that when we're using operating system under POSIX, that our paths are separated by a simple colon, whereas on Windows, a semicolon will be used. That path separating character is an important concept, and while there are other ways to discover whether we're on Microsoft Windows or POSIX systems, note that the sys.path, as imported by the sys module, does not contain the operating system path, but rather a detailed listing of all the directories as well as zip archives that Python will be looking to use when starting up, as well as when looking for imports that we will be using in our own Python scripts. So once again, unlike the operating system path, the Python path will have folders as well as archives, and you will note that many of the folders that were on the operating system path, as shown in the previous slide, will not be displayed on our sys.path collection on Python. One of the lesser-known facts about the sys.path collection, as well as a Python path environment variable, is that the Python path is merely used to prime or set up the sys.path in Python. Once the sys.path collection has been defined in Python, however, a lot of software developers don't know that we can modify that by adding to or changing the list so as to remove or insert our own archives for use in the Python programming world. By modifying the sys.path collection in the sys module, therefore, we have the ability to include as well as exclude multiple versions, unique versions, as well as our own libraries, so as to dynamically modify what Python locates as well as uses on our behalf. It's time for a demonstration, because like you, I too have to protect myself from random upgrades that have been known to cause damage to my computer. On my Microsoft Windows machine, I'm using Python version 3.5, but in this demonstration, everything will work pretty much the same. Because I've noticed that a lot of Python developers have what I call IDE fever, I think it's important to review the fact that although we always run things from the IDE when we're developing things, certainly if we want to make things happen quickly, that the scripts we write in Python, even when executed by an integrated development environment, which after all is simply integrating a development environment to the command line executable, can also be executed standalone. So here we're going to create a new script, and we're going to save it to our desktop as myhi.py. And as, of course, we run it in the IDE toolset, in this case we're using idle, you'll note that it works pretty much as we've all seen and would expect. Once we've run the script, notice how the interpreter will provide us the fully qualified path name to where that script is, and by simply selecting it from the interpreting session and then cutting and pasting it into a command line session, we of course are now free to run that application as well. By way of completing the concept of what the path actually does for us on Microsoft Windows as well as on Linux and OS X, all we have to do is use the attribute command on DOS, or perhaps the find command on POSIX, so as to locate the python.exe file, or if you're on POSIX, it'll be Python 3. And as we locate the file and print out the path that it's on, you'll see the fully qualified path name as we have here on Windows. And by availing ourselves by the echo technique that we just discussed, we can echo the content of the operating system path so as to verify that the version of Python that we are using does indeed match what is on the operating system path. Keep in mind here that when it comes to walking down the operating system path, that both Linux as well as Windows will find the first Python, in this case, that is located along the operating system path and use that executable so as to run our Python script. When teaching more than one class, I've discovered people who had old versions of Python along that path and had included versions, for example, like Python 2.6 or 2.7, higher up on the operating system path. And even when they might have had Python 3 installed, whenever they ran a script using the command line interface, they actually were executing an older version of Python. So a good concept to remember is that whenever we're using a console interface, that the operating system is using the operating system path, and yet while totally different from the Python path, before we get things started so as we can even access our Python path, the operating system will be looking along its own path so as to locate the executable, in this case the python.exe file, that it will use to run our scripts.